Welcome to math class. We are continuing on in the MathWorks 10 workbook. We are starting on unit 5.3, which is the relationship between non-parallel lines and transversals, and particularly about how all those different angles interact with each other. So we're going to start off with the example that's on page 232. Now I'm going to go ahead and label this. My drawing is not as exact as the one in the textbook, but it should be enough to help us understand the concepts that we're trying to learn here. 4, 7, 3, and I'm actually going to add a number. I'm going to add number 10 to the angle right there. Okay, so this unit is actually mostly about definitions. I feel like I'm back teaching an English class all over again. So what they're looking for is we need to know a few things. We need to know what a transversal is. All right. We need to know corresponding angles. We need to know what vertically opposite angles are. Oops. We need to know what alternate, what are we going to start with? Alternate interior. And then we need to know what alternate exterior angles are as well. So those are the lines we got to learn. Now, we can start, or sorry, those are the terms we have to learn. Transversals is the easy one. A transversal is simply a line that crosses through two other lines. So at this point, this transversal actually crosses 3 different lines. So this one qualifies easily. Same with this little line over here, also a transversal. This one over here, transversal. This one over here, also a transversal. Okay, so all of those actually intercept 2 or more lines at completely distinct points, okay, which makes them a transversal. Corresponding angles gets to be a little bit trickier. So corresponding angles is sort of an umbrella term that refers to any angles created by intersecting lines, 2 angles that occupy the same relative position at 2 different intersections. So for instance, basically what they're saying is any angles that wind up being the same as each other based off of the way that the lines intersect. So for instance, the very first example and the easiest example here is we have angle number 2 and angle number 6. These are corresponding angles. They are both angles that are obtuse, or bigger than 90 but less than 180. And both of these are opening towards the interior of our design. These two are corresponding angles. We also have corresponding angles here with 1 and 5, where they are the acute angles, so smaller than 90, facing towards the outside of our structure. So both of those are examples of corresponding angles. The next one we've got to come up with is vertically opposite angles. So what we're looking when we talk about vertically opposite angles is we're looking for a transversal, just like that one, and we're looking for angles that are on opposite sides of it. So they're not on the same, and they have to share a vertex. Okay, they have to share a vertex, which is basically both of them have to have the same point in which their angle is opening off of. So our vertically opposite angles here are actually going to be 2 and 9, or 1 and 8. Those are both examples of vertically opposite angles. They're on opposite side of the line, they're sharing a vertex, and they're in similar positions. So those are vertically opposite angles. The next one up is alternate interior angles. Alternate interior angles is a little bit trickier. what we're looking for there is anytime a line crosses through and we have angles that are on opposite sides of a line, okay? So they're not going to be on the same side, they're going to be on opposite sides of the transversal. Sorry about that, seem to have caught something in my throat. So back to alternate interior angles. So they are angles that are on opposite sides of the same transversal, and they occupy opposite positions between the two lines. So it means we have 8 and 7 are examples of alternate interior angles. So they're on the inside of the shape, they're on opposite sides of the transversal line, and they have opposite positions. Basically meaning that this 8 angle here is below this transversal, and our 7 angle here is above this transversal. So they're on opposite positions of those lines, and they're also on opposite positions of that particular line. And then the last one we have to learn is alternate exterior angles, and this is why I actually had to add in my extra point here, or add in my extra angle that I labeled, because they didn't have examples of this one on this particular drawing. But what I'm looking for is an alternate exterior angle. So it is going to be an angle that is opposite of a transversal. So we've got to be on two opposite sides. The angles cannot be on the same side. The angles are also in opposite positions, so they might be outside or inside of the transversal that's crossing it. In this particular example, they are not, but they have to be outside of the two lines that are being intersected. So if this is our transversal, the two lines being intersected is that one right there and this one right here. In order for this to be an alternate exterior angle, they have to be outside of both of those lines, and they have to be on opposite sides of our transversal. The example we've got on this particular picture is we have angle 5 and angle number 10. Those are our alternate exterior angles because they are outside of the two lines being intersected, and they are on opposite sides of the intersecting line. So that is our first example. So let's go ahead and skip over to the next one. So our example is on page 234. There we go. So what we're looking at here is the relationship between angles in a figure. So I'm going to label this really quick. We've got 1, 2, 3, and 4, 5, 6, 7, and 8. So what they want you to do for this particular question, and I'm guessing my protractor is all the way up here, is they want you to basically be setting up your protractor so that you can look and see how much each angle is. And then you're going to be calculating them, and this one goes here, and seeing how close those numbers are to being the same. So this is not going to be a perfect demonstration because I just had to whip these up on the smartboard using the tools I had, but let's go ahead and take a look at what happens if we line up our angle 1. So we need to know how much angle 1 is. So I lined up my bottom line on my compass here with my angle. What I'm seeing is that my angle is about 140 degrees. Okay, so I'm going to set that up. I can quickly and easily figure out what angle 2 is because my protractor just so happens to be set up on that particular position. But if I look here, I know that angle 2 is going to be 40 degrees. Okay. I'm going to now spin this sucker around and I'm going to check and see how much is angle 3. So I'm going to line it up right there with a nice flat line. Angle 3 equals, looks like 140 degrees. Angle 4, so I've lined up my bottom here. I'm going to line up my top here, equals 40 degrees. What you should find out if you've done this right, and I'm actually going to delete that. Oh, maybe I'm not going to delete that. Okay. What you'll actually find out is that these corresponding angles, so angle 1 and angle 3, are going to be equal. Okay. You'll notice that angle 2 is going to equal angle number 4. You can go ahead and try 5, 6, 7, and 8 on your own, but if you're savvy, what you'll notice is that 5 and 7 are going to be the same. 8 and 6 are also going to be the same. Go ahead and give that a try, or take a look at some of the questions in your textbook. So they're going to be asking you to use your protractor and take a look at some angles and compare their sizes. And what you're looking for is the patterns. Which angles wind up equaling each other? And you really want to keep an eye on for that pattern, because it's going to be useful in our coming up assignments. So that's all for today. I'll see you in math class.